Okay, good afternoon, everyone. Thank you all for being here today. Very excited to be here, so thank you for SINAInnovations Committee for putting this on. So my name is John Capua. I'm a second-year medical student here at Mount Sinai, and today I'm going to be talking about a device that me and my younger brother Christopher invented called the Automated Ventilator with Assisted Compressions. So what's the problem? Out-of-hospital cardiac arrest affects approximately 326,000 people in the United States each year, with cardiac disease, according to the World Health Organization, being the largest cause of death in the world. Unfortunately, in the United States, we have a dismal survival rate in out-of-hospital cardiac arrest, 7.6%. It's a very, very low number. Of course, there are a lot of factors that contribute to this. For example, following cardiac arrest, irreversible brain damage typically occurs within 4 minutes. This is unfortunate because the average emergency medical services response time is around 5 minutes. So there's an entire minute where the patient is feasibly being unattended to and they're experiencing adverse outcomes. So in order to mitigate this, we need to have a population, a bystander population, that's empowered to perform life-saving CPR for these patients. So as we know, we all learned back in middle school or high school, CPR is a combination of mouth-to-mouth ventilation and chest compressions. Unfortunately, CPR has a lot of problems. The first problem is that bystanders are simply not willing to perform it. Several studies have shown that bystanders don't like performing CPR because of the difficulty of the procedure, and then secondly because there's a fear of disease transmission, specifically during the mouth-to-mouth portion of CPR. This actually prompted the American Heart Association in 2010 to update their guidelines for CPR and institute chest compression-only CPR. However, of course, an ideal resuscitation technique would include both adequate ventilation and chest compressions in order to give the best possible treatment to the patient, and that's where the AVAC comes in. So the AVAC is a lightweight portable ventilator that can be successfully used by lay responders in out-of-hospital sudden cardiac arrest scenarios. The device has 3 main components. First, it has an i-gel laryngeal mask airway, which is inserted into the patient's mouth and secures their airway for the duration of the resuscitation. Next, it contains a computer controller, which regulates the timing and flow of oxygen to the patient. It also has an internal audio-visual metronome that assists the responder in performing the properly timed and rated chest compressions. Finally, it contains a compressed oxygen tank that is able to deliver 100% oxygen to the patient. So there are several advantages of the AVAC compared to CPR. First, the rescuer is able to secure the patient's airway at the beginning of the resuscitation. That's important because then we can deliver ventilation to the patient throughout the resuscitation. It also allows them to perform continuous chest compressions. Again, this is important because continuous chest compressions has been shown to promote circulation throughout the patient and, of course, deliver better, more nutrients and oxygen to the tissue during the resuscitation. Additionally, the AVAC times the downward compressive force of the compressions along with the ventilations, therefore increasing intrathoracic pressure and further promoting promoting circulation. And finally, with the AVAC, we're delivering 100% oxygen to the patient, as opposed to the 15% oxygen that's in exhaled air. So back in 2014 and early 2016, we received 2 U.S. patents for the device, and we currently have patents pending in Europe and Asia. And through this patent process, we've actually, and through our dealings with the patent office, when they asked us to review a couple of pre-existing patents, we really found that the AVAC is the first device in this space. All of the other devices they asked us to review were mainly continuous ventilators for use in the operating room. So the AVAC is really the first device that's first meant to be portable, and secondly meant to be used by lay responders. That's a very important point. The whole idea of this AVAC is that it's meant to be used by lay responders for out-of-hospital cardiac arrest. So we pitched our idea to a couple of news agencies back in 2014, and we were really overwhelmed with the response we received. We had an article in USA Today, Journal News, ABC, Channel 7, Fox 5, Westchester 914 Magazine, and even a quick blurb in Men's Health. And, kind of looking back onto this, the reason why I think we had such a large media outcry or outpouring of support really was because A, the AVAC is a simple solution, and it's relatively intuitive, which is why I think it's a really great idea. And second, cardiac disease is so prevalent. Everyone in this room probably knows someone in their family or a friend who's been afflicted by cardiac disease. And so I think the public at large is really looking for a good solution to solve this problem. So we did a quick market analysis, and since the AVAC is really the first device in this space. We look to another device that's typically used in cardiac arrest scenarios, and that being automatic external defibrillators, or AEDs. These are the devices that you place onto the patient's chest and it shocks their heart back into rhythm. So AEDs, the global market for AEDs back in 2012 was around $616 million. And the United States has been purchasing around 200,000 devices annually, and that number has been doubling ever since. And there's really two reasons why the AED market has grown so explosively in the past few years. First, public access defibrillators are mandatory in all places of public assembly, those being places like office buildings or schools or malls. The idea is that you want AEDs in places where they're most likely to be used, where the largest populations of people typically aggregate. And that's a law that stands in the United States, Japan, and several European countries. Secondly, the price of AEDs has been slowly dropping over the past few years. And that's made the purchase of AEDs to consumers a much more feasible option. It's no longer uncommon for you to walk into, say, a restaurant or even someone's home and they have an AED in the room. Again, because the prevalence of cardiac disease is so large, it's an important thing to have. So AEDs are typically priced at around $1,000, and we expect the AVAC to be costing around $500, so around half that price. So we anticipate that the AVAC would very closely follow the AED market. So just to go over a couple of milestones we've recently hit and some more milestones that we plan to start up in the coming years. So again, like I said, we received a U.S. patent back in 2014 and 2016, and we've started a business relationship with Trinity Medical Devices, and they're essentially a company that helps young companies like my brother and mine eventually initiate FDA testing and go to market. We incorporated, my brother and I, we started the company. We're officially the Capua Partners LLC, which has been very fun. So we're using that as the face for our for the device. And the two big milestones that we need to hit in the coming years are, first, to initiate FDA testing. So we have to start the 510K pre-approval process. We anticipate the AVAC will be classified as a Class 2 device, and that's just based on the fact that current continuous ventilators are Class 2 devices. And then we have to work with the FDA. We have to work with the American Heart Association and start discussions with them. And I think they're going to really like the idea of the AVAC because it's essentially what they're already doing with AEDs. And we have to see if we can incorporate the AVAC into basic life support protocols and CPR classes. So with that, I want to thank everyone for your time. Again, my name is Johnny Capua. Our website is www.avaccpr.com, and I'd like to take any questions you guys may have.
Can you share with us the 510K, the regulatory path? What would it take to get this device approved? How many patients do you need in the trial? How long will it take?
So that's a really good question, and we're currently looking into those details right now. So I don't have a concrete answer for you quite yet. I know if we were to follow the route that the AED has taken, basically what AED did back maybe 10, 20 years ago, probably even longer, was they paired up with EMS companies, and they said, okay, listen, every time you go to a cardiac arrest protocol, right, try using the AED. And the idea is that you would use the AED on the patient and gather data that way. And if the AED doesn't work for whatever reason, the EMS personnel had the expertise to say, okay, we're going to put the AED over here, we're not going to use it, and we're going to do, say, typical CPR protocol, do chest compressions, mouth ventilation. And I think that's the best route we're going to do with the AVAC. So, because I mean, it's very difficult to ask someone to enter a randomly controlled trial and say, okay, well, if you ever have a cardiac arrest scenario, which is obviously very unlikely for most patients, we're going to try this novel device on you. And it would just be very difficult to organize in that way. So I think we would follow what the AED has done previously.
Thank you.
Thanks, John. That was great.
Thank you.
What evidence do you guys have that it works?
So our trials are based on, they're all simulator trials. So we use a layered-ol SimMan mannequin, which is the mannequin that's typically used in anesthesia simulations. So the mannequin is a really great device. It simulates body physiology as much as a simulator can. So to give you an idea, it has like working lungs, working heartbeat, has peripheral pulses, You can perform emergency procedures on the mannequin. So it's really as anatomically accurate as you can get with the mannequin. And we performed 2 studies. So the first study was to evaluate which airway device would be best used by lay personnel. So we compared the eye gel and its insertion and ventilation using the eye gel. Bag mask ventilation, so that's the mask that goes over the patient's mouth, and you use the bag and ventilate that way. And the third thing we compared was with mouth-to-mouth ventilation, and we saw that the eye gel was A, most preferred by all of the participants, and then B, it was the most likely to deliver adequate ventilation times, minute ventilations, all these metrics that we measured. So that was the first study. The second study was evaluating the AVAC, so the entire device once it was built, compared to typical CPR with mouth-to-mouth ventilation, and we observed the same results, which was really great. And those studies were around, I'd say 50 participants for the first and around 50 for the second. So it was around 100 participants so far.
And and just to continue on that, from the real world, how early do you have to intervene? You know, if you compare, say, hospital to, someone out having a heart attack out on the street, how quickly do you need to get oxygen there?
Okay, sure. I think it's most important to get oxygen as early as possible. I think there are several studies that have shown that if lay responders intervene early, you have better outcomes, which of course makes intuitive sense. The 2 main things you want to do, and which is why CPR is conceptually a good idea, is you want to establish ventilation, so you want to get oxygen back to the patient, and you want to circulate that oxygen throughout the patient's body. So like as I said earlier, when we have irreversible brain damage occurring around 4 minutes because the brain is hypoxic, the quickest that you can establish circulation and ventilation is going to help. So the AVAC, there was actually, so in our study we found that time until first chest compression was slower with the AVAC because the patient was establishing the airway. But then if you look at total amount of ventilation given throughout the procedure and the properly timed chest compressions, the AVAC outperforms CPR very significantly.
So I assume you'd start by training people at sites where there are already AEDs. So have you done any survey to see, what type of training would be required and how likely a bystander would be to be comfortable using this device?
Right, that's a great question. So obviously training, and that's why we have to work with the American Heart Association. Training is going to be very important with this because obviously I feel that the AVAC is very simple, but then again, I kind of created it, so I think it's easy to use. But we would have to have training incorporated into basically in CPR classes, we need to have training to use the AVAC as well, just like you're trained in CPR classes to use an AED. We created a simple training video for our study. We created 2 independent training videos, one for mouth-to-mouth ventilation CPR, and then one for AVAC CPR. And so those are the 2 videos we created, and they were relatively short, 30 seconds to 60 seconds. But again, we would obviously have to really refine it and make it more robust if we were to, roll this out to all basic life support classes.
Mm-hmm. And you mentioned the price drop of AEDs. So what gives you confidence that you could actually achieve margins with this device that would, make the company profitable?
That's a great question. So we built the device with around $100 to $200 worth of parts. I don't remember the number off the top of my head. And this is all stuff that we basically bought at the hardware store. It's all the solenoids and valves and pressure relief valves and tubing. So I imagine that our prices would go down once we hit manufacturing and we get to a scalable size. And the technology itself is simpler than an AED's. AED, when you place the pads onto a patient, has to analyze their current rhythm, has to deliver a significant electrical shock. The AVAC is really just, you turn it on, it starts ventilating, and the metronome is going off, letting you know when to do chest compressions. It's a much simpler technology.
Thanks.
No problem.
And who would pay for this?
So again, it depends how we work with the American Heart Association, because we would hope to follow how, again, as I've said, we would hope to follow AEDs as much as possible. So the idea is that you would have them in all places of public assembly, so large office buildings or malls or companies that own those large buildings, they would be the buyers. And then also we would have a second, marketing effort to sell directly to consumers for their individual homes or for small businesses.
If you approached sources of non-dilutive funding, like for example, I was thinking perhaps the Department of Defense for military applications or some other sources of non-dilutive funding for this type of program.
We actually have considered that, and I think that was one of the first things we thought the AVAC would be applicable for, would be on the battlefield. You could use something like this very quickly to secure airway and transport someone who was wounded. We haven't really pursued that avenue yet, but it's always been on the table. Okay, thank you guys very much. Appreciate it.